Okay, the next one is the properties of root locus. In this part, the properties of root locus lead to a rapid sketch of without having to factor the denominator of the closed loop transfer function. Given the transfer function of the closed loop control system, where the equation is kg over 1 plus kgh, g is the forward pass transfer function, while h is the feedback path transfer function. So from this equation, a pole, which is usually labeled as S, exists when the characteristic polynomial in the denominator becomes 0, or we equalize this denominator equal to 0. So 1 plus kgh is equal to 0. We rearrange this equation. We take this 1 to the right side. We have kgh equal to negative 1. This is also equal to the magnitude 1, and this is the phase where this is actually is an odd multiplication of 180 degree, 2k plus 1. K is 0, plus minus 1, plus minus 2, plus minus 3. So this part, okay, this is the magnitude criterion, where the magnitude criterion is magnitude of kgh is equal to 1. Then this part is actually the angle criterion. The angle of kgh is equal to the odd multiplication of 180, which is 2k plus 1 multiplied with 180. So this equation implies that if a value of s is substituted into the function kgh, a complex number results. If the angle of the complex number is an odd multiple of 180 degree, that value of s is a system pole for some particular value of k. But if the angle of the complex number is not equal to the odd multiplication of 180, meaning that the value of s is not part of the particular value, is not a pole for the some particular value of k. So based on this equation, we can determine the value of k if the angle criterion is equal to 180, and we determine the value of k, the unknown gain k, by rearranging this equation, which is k equal to 1 over magnitude of gh. Okay, this is an example given. So it has kgh equal to this transfer function. This is open loop transfer function. And then we determine the closed loop transfer function. Okay, this is the open loop transfer function. We want to check whether the point S given in the question is a closed loop pole system for some value of gain k. Okay, to satisfy the previous equation, magnitude criterion and also the angle criterion. Magnitude criterion equal to 1 and also angle criterion equal to odd multiplication of 180. So based on this open loop transfer function, first we draw the pole zero map, where we have two zeros, negative 3 and negative 4, and also we have two poles, negative 1 and negative 2. Okay, next, given in the question, for example, a point negative 2 plus j3. Okay, this is negative 2 plus j3. We draw in the same pole zero map. We need to check whether this point, the point given, negative 2 plus j3, is a part of the pole for the system, for the closed loop system, by varying the gain k. Okay, to check this one, we need to prove whether it is equal to multiplication of 180 or not. If it is equal to 180, meaning that this point is part of the root locus of the system. But if this one is not equal to 180, this point is not part of the root locus. Okay, how to determine using this equation? First, we draw a straight line from each zero and each pole to this point given. Okay, negative 2 plus J3. And then we need to determine the angle from each pole N0 to that point. Okay, we label this one theta 2, theta 1, theta 2, 3, and 4. We determine theta 1, which is arctangent 3 over 2, 3 over 2. So the magnitude from this point, this at theta 1, which is from -4 to this point, is 2. So 3 over 2, arctangent 3 over 2, which is 56.31. And then for theta 2, we have arctangent 3 over 1. Okay, 71.57 degree. For theta 3, at this point, so the angle is 90 degree. And for theta 4, okay, using this one, arctangent 3 over 1, we're actually calculating this angle. So to determine this theta 4 angle, we need to, using this equation, 180 minus the angle of this one, then we'll get the angle of theta 4, which is equal to 108.43 degree. Okay, please remember, we need to use this equation when we need to prove the multiplication, the odd multiplication of 180 degree. The equation is the summation of angle of zeros minus the summation of angle of poles equal to odd multiplication of 180, or 2k plus 1 multiplied with 180. In this case, k equal to 0, 1, or 2. So in this case, theta 1 and theta 2 belongs to zeros. So theta 1 and theta 2, so this is positive. Theta 3 and theta 4 belongs to poles, so this is negative. So when we settle this equation, the answer, the final answer is negative 70.55, which is not equal to 180. Meaning that this point, negative 2 plus J3, is not a point on the root locus, or alternatively, minus 2 plus J3 is not a closed loop pole for any gain. Okay, so you also can try this practice one using the same method of angle criterion. Okay, first you need to calculate the angle by drawing the open loop pole. Okay, open loop pole N0, and determine the angle to this point, negative 3 plus J0, and then determine if the point specified in A is on the root locus or not using the angle criterion, 2k plus 1 multiplied with 180. If the point specified in A is on the root locus, meaning that the angle is equal to 180, and then find the gain k using the magnitude criterion, k equal to 1 over magnitude GH.